Hello everyone, I welcome you all for this lecture. So, we are studying the atoms chapter. Okay, so in this video, we will study the line emission spectrum of hydrogen, line absorption spectrum of hydrogen, energy level diagram for hydrogen atom, indicating different series of spectral lines, and de Broglie theory. So, these 4 points we will study in this video. First one, that is a line emission spectrum of hydrogen. When the hydrogen gas is excited, the electrons of an atom jumps to different higher energy orbits too, depending upon the quantity of energy absorbed by them. Then, while retaining to their orbits, electrons emit radiant energy of different wavelengths. Okay, so whenever the hydrogen gas is excited, the electron will jumps the higher energy level to lower energy level. After that, if it wants to retain their orbit, then again it emits some radiant energy. Okay, or that is also known as photons of different wavelengths. Then whatever the spectrum of radiation is present in that, that is known as line emission spectrum. This spectrum contains some bright lines with a dark background. So this is about the line emission spectrum of hydrogen. So in last video we discussed about the Bohr's atomic model. In that, according to Bohr, the energy of emitted photon E is equal to E2 minus E1. Okay, so where the E2 is what? That is a higher energy level and E1 is a lower energy level. So here the photon, the packet of energy or the emitted photon or that radiation h mu is equal to E2 minus E1. That we studied in Bohr's postulates. So according to that, here if the electron wants to regain their original orbit, then the electron will emit some energy. Then that for this different wavelengths, then the spectrum of radiation is known as what? Line emission spectrum. Okay. The next one, that is the line absorption spectrum of hydrogen. When white light of continuous spectrum is passed through the cold hydrogen gas, some dark lines are seen in the spectrum. This kind of spectrum is known as the absorption spectrum, and the dark lines are the wavelengths absorbed by the hydrogen gas. So whenever the white light, okay, that will be from white light whenever the spectrum is passing through this, okay, of cold hydrogen gas, then the some dark lines are seen in that spectrum, and this kind of spectrum is known as what? Absorption spectrum. Okay, the cold hydrogen gas will absorb that spectrum, so that is meaning the absorption spectrum. And the dark lines are the wavelengths absorbed by the hydrogen gas. So that are the line absorption spectrum of hydrogen atom. Then next one, the spectral lines of hydrogen atom using Bohr's theory. So in last video we derived this equation according to Bohr's atomic theory. So 1 by lambda is equal to R into 1 divided by N1 square minus 1 divided by N2 square. Okay, so if you want to see, you just pause this video and you go through the atoms part 2 video. There you will see the derivation or expression for this So that we have studied in last force postulate and even the expression for it. Okay, so we'll see the some spectral series, okay, according to Bohr's theory of hydrogen atom. So according to Bohr's atomic theory, 1 by lambda is equal to R into 1 divided by N1 square minus 1 divided by N2 square, where R is what? The Rydberg constant. And here, according to Bohr, there will be 5 series. The first series is Lyman series, then second one is Balmer series, then Faustian series, Brackett series and Fund series. So for the Lyman series, the 1 by lambda value is equal to, that is R in bracket 1 divided by 1 square minus 1 divided by N2 square, where N1 is equal to 1 for this series and N2 is equal to 2, 3, 4, 5 and so on. Like this, the Lyman series is having the value 1 by lambda value is equal to R into 1 by N 1 square minus 1 by N2 square. So this lies in ultraviolet region only. Okay, so this Lyman series lies only ultraviolet region. So this is about the Lyman series. So sometimes if the N2 value, okay, they will tell about the first in 2, 3, 4, 5 and so on. And the N1 value is always 1 in this Lyman series. Then second one, for Balmer series, the 1 by lambda value is equal to R into 1 by 2 square minus 1 by N2 square, where N2 is 3, 4, 5, 6 and so on. And the N1 value for Balmer series is fixed, that is 2 only. And N2 values are varies, and that is 3, 4, 5 and so on. And it lies in visible region and UV region only. Okay, so in visible and ultraviolet region only it is this series is present. So next one, that is Faustian series. Okay, third series, that is Faustian series, and the 1 by lambda value is equal to R into 1 by 3 square minus 1 by N2 square, where the N1 value is 3 for this series and N2 value is 4, 5, 6, 7 and so on. And it lies in infrared region only. Next one, for Brackett series, that is 1 by lambda is equal to R into 1 by 4 square minus 1 by N2 square, where N2 is 5, 6, 7, 8 and so on. And this series lies in infrared region only. For Fund series, the 1 by lambda value is equal to R into bracket 1 by 5 square minus 1 by N2 square, where N2 is 6, 7, 8 and so on, and N1 value is 5 only for this Fund series, and it lies in far infrared region only. Like this, the series of spectral lines, okay, for hydrogen atom is having the 5 series: Lyman series, Balmer series, Faustian series, Brackett series and Fund series. So after that, this is the energy level diagram for different spectral lines. So for Lyman series, N1 is equal to 1. And the N2 value is, suppose the Lyman series N2 value you should take as a 2, 3, 4 and so on up to N is equal to infinity value. And here, so it is having the total energy as a minus 13.6 electron volt for ground state. Okay, for Balmer series, the N1 value is 2 and N2 value is 3, 4, 5, 6 and so on up to infinity. And for question series, the N1 value as a 3 and N2 value as 4, 5, 6 and so on up to infinity. And bracket series, the N1 value as a 4, N2 value as a 5, 6, 7 and so on up to infinity. And for fund series, the N1 value is 5 and N2 value is 6, 7 and so on up to infinity. Like this, the here for x-axis, okay, that is a ground state. You should take the here for y-axis the total energy electron volt, okay, and if you will find that series is okay for first state, okay, or it is also known as ground state, that is having the total energy as a minus 13.6 electron volt. For second state level energy level, okay, that is minus 3.4 electron volt. For third it is minus 1.51 volt, and for fourth series it is minus 0.85 electron volt and so on. It continues up to n as a infinity. Like this, it is having a total energy as a in electron volts. After that, we'll see the de Broglie theory. Okay, so de Broglie theory. In this theory, we'll see the since the electron does not radiate in stationary orbit, the wave associated with it must be stationary wave. Okay, so according to Bohr, the nucleus is present in center. After that, the some circular orbits are there. In that fixed orbit, the electron is revolving, and electron whenever it revolves, okay, and it is stays in only stationary orbit and without the emission of radiant energy, okay, it is revolving, and the angular momentum of electron in the stationary orbit is nh divided by 2 pi, and the electron does not radiate some energy in its stationary orbit. So these all we have studied in the Bohr's postulate, and since the electron does not radiate in stationary orbit, the wave associated with it must be stationary wave. Okay, so whenever the nucleus is present in center and for a circular orbit the electron is revolving, and the for that stationary orbit, okay, the wave with it will be stationary wave, okay, and that orbit is having a nature like a stationary wave. Then after that, the according to de Broglie theory, the energy will be carried away with the wave and the path of the electron will be spiral ending with nucleus. Okay, so whenever the electron is revolving in a stationary wave and like orbit, okay, that is orbit like stationary wave, and it carries some, if it carries some energy with it, then what happens, the electron will be lastly it joins to nucleus only, because whenever for a fixed orbit if it is revolving, then if it takes some energy for every time, then for every circular path, the energy will be decreases and the electron will be revolving as a spiral ending and it joins with nucleus only. Then the wave representing electron should be such that its value becomes the same at every point whenever it comes again to the same point. Means what? Whenever the circular orbit is fixed, the every time the radius of that circular orbit will not decreases, but the orbit will be like a, suppose it moves like a wave, and if you will find the wave nature, okay, that wave, the always the resultant of that path is equal to the fixed orbit circular path, or the electron should be revolving in the nucleus in such a way that the when whenever it comes again to its same point, the total, the whatever the rotation will be there, that as the same. Okay, so and if it will vibrates little bit, and after vibration, okay, after rotation of that wave, if it will comes at same point, then again the radius of that orbit will be same. Then next one, this out of all orbit permitted by the classical physics, electron waves select only those orbits where the circumference is integral multiple of its wavelength. So whenever the orbit is permitted, then the all the electrons, the all orbit permitted electrons will be select the some circumference of the orbit, okay, and that is having the integral multiple of its wavelength. So suppose if you will see, suppose the circular orbit is present. In that circular orbit, okay, so de Broglie argued that the electron in its circular orbit as proposed by Bohr must be seen as a particle wave nature, and the wave traveling on the string, okay, like string particle wave, and it can lead to standing wave under the resonant conditions. In a string, standing wave are formed when the total distance traveled by the wave, that the down the string and back is one wavelength, or it is two wavelength, or any integral number of wavelengths. The waves with the other wavelengths interference and the interfere with themselves upon the influence, and their amplitudes quickly drop to zero, and again it comes to its original shape. For the electron moving in nth circular orbit of radius r, then the total distance of the circumference of the orbit, which is having 2 pi r, because the circumference of the circle is 2 pi r. Suppose the nth orbit, the circular orbit, and the radius will be suppose rn, the total distance of the circumference is 2 pi rn. Okay, so this is according to Bohr's theory. Then after that, the de Broglie explained the Bohr's quantization rule. Okay, that is nh by 2 pi in its own way. So according to de Broglie, the electron in a circular orbit around the nucleus exhibits wave nature. Okay, so according to Bohr, it is only the fixed circular path, but the de Broglie explains here the nucleus is in center and electron is revolving in a circular orbit, but the orbit is having the wave nature. Okay, so here the dual nature will be explained by de Broglie, and here that is particle as well as wave nature. Like this, the electron is having both nature, that explained by de Broglie. For an electron moving in the nth circular orbit of radius r with the speed v, then the distance traveled is equal to circumference of the orbit. Okay, so that is whenever for the electron is moving nth circular orbit, okay, n may be any number, and suppose it is having the radius as a small r, and with speed v it is moving, then the total distance traveled is equal to, obviously it is the circumference of the circle, because it is a circular orbit, and that is equal to what? 2 pi r. For stable orbit, the 2 pi r is equal to integral multiple of waves, okay, or the de Broglie waves. Then the 2 pi r is equal to circumference of the circle is equal to n into lambda. Okay, so lambda is what? The integral multiple of waves. Okay, suppose here the 2 pi r is equal to n lambda, where the lambda is a de Broglie wavelength and n is what? The 1, 2, 3 and so on numbers. Then suppose if 2 pi r is equal to n lambda, suppose this is equation number 1, and according to the de Broglie wavelength, lambda is equal to h divided by mv. Suppose it is equation number 2. From equation 2 and 1, okay, so we will get 2 in 1, we will get the 2 pi r is equal to nh divided by mv. Okay, so n is the any number 1, 3, 1, 2, 3 and so on, and the where the lambda is a de Broglie wavelength, then the 2 pi r is equal to nh divided by mv. Okay, in this equation number 1, lambda value you put as a h by mv. So that is only 2 pi r is equal to nh divided by mv. That is, you should take the mv this side and the 2 pi as a RHS side. Then that is mvr is equal to nh divided by 2 pi. But the mvr is equal to L, capital L, and that is only the angular momentum. Then the L is equal to, here the instead of mvr you put L, L is equal to nh divided by 2 pi. This is the Bohr's quantization condition. Okay, so like this, the de Broglie explains the Bohr's quantization condition, that is L is equal to angular momentum is equal to what? The nh divided by 2 pi. Okay, and the only thing, different thing is what? According to Bohr, the whatever the orbit will be there in where the electron is revolving, that is a only circular fixed orbit, but according to de Broglie it is a having the not only the circular orbit, okay, not only the fixed orbit, but it is having the both nature. Okay, that is a wave nature as well as particle nature. Okay, so like this, The de Broglie explains the Bohr's quantization rule about it. So, thank you. Here, this de Broglie explanation is completed, and after that, we'll see the numerical problems where you should find the some wavelengths of spectral series of hydrogen atom. Okay, so here for the numerical problems, you should find the different wavelengths of spectral series of hydrogen atom. That is 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. If Lyman series is there, it is 1 square. For Balmer series, n1 value as a 2 square. Okay, here this is 2, n1 value as a 2. For Paschen series, it is 3. For bracket series, it is 4. And fund series, it is 5. Okay, so depends on the series is whatever given in question or that numerical problem. And n2 value also whatever mentioned in that problem, you should see properly and put in this formula directly, you will get the answer. Okay, so here this is very important formula that is used, and the in atoms chapter, okay, these equations are very important. Okay, and after that it is very easy to solve the problems. Okay, so second one, you should find the wave number, okay, using this formula, and frequency of particular line, okay, of spectral series, and after that the Rydberg constant. Okay, so like this, these three formulas, that is the for wave number, it is r in bracket 1 by n1 square minus 1 by n2 square. And for frequency, mu is equal to c by lambda is equal to rc in bracket 1 by n1 square minus 1 by n2 square. And for Rydberg constant, r is equal to e raised to 4m divided by 8 epsilon naught square h cube c. Okay, so you should remember these four formulas. Okay, and these are very important, and only in this chapter, okay, using these formulas only you are having the problems. Okay, numerical problems you should solve. So I will give some worksheet in your WhatsApp, and we'll see the I'll solve it. Thank you.